Welcome to Conceptual Cambridge. Today we are going to cover coordinate geometry, and these are all the subtopics we'll be covering. So let's begin. So what is coordinate geometry? It is a branch of mathematics that combines geometry and algebra together to solve various problems. For this topic you should already know what are the coordinate points, but in case you don't, let me explain it to you. So for example, this is the coordinate axis, this is the x-axis, and this is the y-axis. If I was to draw a point over here and ask you to determine its location, then we will determine its location according to coordinate axis, how much it has moved in the x scale and how much it has moved in the y scale. So for example, we can say its position is 2 in the x scale and 1 in the y scale. This will be very important in coordinate geometry. So how does this combine geometry and algebra together? So let's say I have a triangle over here like this, a right angle triangle, and you know its coordinate points, all three of them. You can use this and algebra together to find out more about this triangle. We are going to discuss what you can find out in the next slides. So let's do that. So first of all, we have finding the length of a line. So let me draw out a line and take some coordinate points. So as you can see here, I have drawn out a line and have taken 4, 2 and 2, 1 to be the coordinate points. So for finding the length of a line, how long this line is, what we are going to do is first of all find the change in x and change in y. So you can already see that the change in x will be 4 minus 2 is equal to the change in x, and for y it will be 2 minus 1 is equal to the change in y. You can also see that when I draw this out, the change in x and change in y, it will become a right angle triangle like this. So let me write down the change in x and change in y. So as you can see, 2 and 1. So now we can find the x, which is the length of the line. So for finding the length of the line, you should already know Pythagoras theorem, which is c square is equal to a square plus b square. Now you can just input the values into that and you will have your answer. So now let's move on. So now finding the midpoint of a line. Let me take the same line and the same coordinates over here. So what is midpoint? First let's discuss that. So the midpoint of a line will be whatever is in the middle, the points which are in the middle. It is just what the word is. Now for finding the middle coordinates, we already know the change in x and change in y. So let me just draw that out. This was the change in x and this was the change in y. Change in y was 1, 4 minus 2, change in x was 2. So we know these two things. We are going to use this to find the midpoint of the line. So as you know, the midpoint should divide the line equally into two parts. So what you can understand from this is that there will be two more triangles like this and like this, which are equivalent. Let me just erase a second. So something like this. So this change in x will be divided among these two lines, which means the change in x is 1 over here and the change in x is 1 over here. Same with the change in y, so this will be 1 over 2 and this will be 1 over 2. So now for finding the midpoint, all you need to do is add 1 to the coordinate over here. So 2 plus 1 is equal to 3. and for y do the same thing. 1 plus 1 over 2, which is 3 over 2 or 1.5. So now you have your middle coordinates 3 and 3 over 2. Or if you don't want to do this, you can also take these two coordinates. So for example 4 and 2, and you can divide it by 2. This gives you 6, and 6 over 2 is equal to 3. Same with the y coordinate, 2 plus 1 over 2 is equal to 3 over 2. So these are the midpoint of the line. Now moving on to gradient. So finding the gradient of a line, let me take the same line and the same coordinates again, as you can see. So first of all, let's discuss what is the gradient. So the gradient is basically the slope of the line, how steep a line is. We define gradient to be rise over run. Let me write it over here. Rise over run. And now we need to discuss what is rise and what is run. So to discuss rise, you can imagine a balloon, for example, like this. What does the balloon do? The balloon moves upward. It rises. It rises upwards. So what rise means is movement in the y direction, or basically the change in y. And for understanding run, you can imagine a person on a racing track, and which direction can he move? He can only move over here or over here, which means this is the change in x-axis. So run is change in x-axis. So we define gradient as change in y over change in x. So to calculate the gradient of this line, now let's see, the change in y is 2 minus 1, which means 1, and the change in x is 4 minus 2, which is 2. So this is the gradient of the line, and the gradient is known as m. Now let's move on. So now let's discuss parallel and perpendicular lines. Firstly, we are discussing parallel. As you can see, I've taken two lines over here and some coordinates. Now let's find their gradients using those coordinates. The gradient was change in y over change in x. So the y coordinate 4 minus 3 over change in x 6 minus 4. So this is your gradient, which is equal to 4 minus 3 1, and 6 minus 4 2. 1 over 2 is your gradient, and for this line you can do the same thing. 2 minus 1 over 4 minus 2, which is equal to 1 over 2. So for parallel lines which will never meet, the gradient will be same. This is what we have established, and you need to remember this. Now let's move on to perpendicular lines. So for perpendicular lines, you should only know one thing, that m1 into m2 is equal to minus 1. This is what you need to know, and you can rephrase it like this, minus 1 over m. So for example, I can say the gradient of this line over here is 1 over 2. Now to find the gradient of the perpendicular line, I can just put this into the formula. So let's say this is m1 is equal to m1. So m1 into m2 is equal to minus 1. So minus 1 over m1 will be our perpendicular lines gradient. So let me just minus 1 over 0.5. So what this means is this will give me minus 2. This is our gradient for the perpendicular line. You need to remember this, as this will come very often in this topic. Let's move on to equation of a line. So equation of a line. What is the equation of a line? It is just an algebraical form of representing the set of points You already know the general form in your IGCSE math, which is y is equal to mx plus c. But in A level math, you will know this, which is just the formula for the gradient, change in y over change in x, written in another form. This is more easier, as for this you don't need to know the y-intercept. So let's discuss what are the variables over here in the general form. So what is y? As I already discussed, this was the rise, which means up or down, and this was the run, which was how much forward or how much behind something is. And you already know what is m, which is the gradient, change in y over change in x, or rise over run. Now what is c? Basically, for example, let me draw something like this. What is the y-intercept? The y-intercept is the point at which the line crosses the y-axis where x is 0. So for example, something like this can be c. This is our c. The point where the line crosses the y-axis is known as the y-intercept, or x is equal to 0 at this point. Alright, let's move on. So now let's find the equation of a circle. So this is going to be derived from the Pythagoras theorem. Let me draw the triangle. As you can see, I've drawn the triangle and taken the center of the circle as A and B coordinate. So now let's find the equation of a circle. This needs to be found from the Pythagoras theorem, which was c square is equal to a square plus b square. So what is the change in your x coordinate? Let's see, this will be the change in x coordinate, which is equal to x minus a, and your change in y coordinate will be y minus b. So we are going to use these two things. Let's put it into the Pythagoras theorem. So c square means r square, and now a square, which is the change in x minus a whole square, and now plus change in y whole squared, which is y minus b whole squared. This will be the general form for the equation of a circle, as you can see over here. For this, you need to remember that a and b are the center coordinates, as you can see over here. So, and over here, as you can see, this is written with minus a and minus b. The sign has been switched. You need to remember this. And for radius, you need to also remember that in the general form it has been squared. So for finding the radius, you just need to take the square root of this. So alright, let's move on. Some things that you need to remember for this topic. The angle in a semicircle is a right angle. It doesn't matter where you make it. So for example, let's say I make an angle over here like this will also be a right angle. It just needs to touch the circumference. Or I make something like this will be 90 degrees. So it doesn't matter where it is, there will be a right angle. And now the other two are very basic things. As you can see here, the perpendicular from the center of a circle to a chord bisects the chord. The chord can be, so first of all, as you can see, the perpendicular can be something like this, something like this, something like this. So if the chord is over here, something like this, it will obviously be 90 degrees. Same with the rest. We draw it like this. This will be 90 degrees. This will be 90 degrees. Now for the last one, you can see this is also just common sense. So for example, if I was to draw a line from here to over here and then take a tangent over here, which is just a line like this, a straight line, this will be 90 degrees, or it can be over here or over here, or any point which touches the circumference and makes a tangent, there will be a right angle. This is something that you need to remember, as this will come in questions. So alright, so this topic has come to an end. So in the next video we are going to discuss circular Meyer, right?